Hey guys, just want to go over your trigonometry test and just kind of show you the answers um, and see what we got. And what I did was, I think I got permission from a student, and I don't want to use their name, but this student got a perfect score, which is great. I mean, a perfect score is great. But what I really liked about this student's test is this student did a really nice job of just showing their work really well. And so I think it would be good for you guys to see the work just laid out. And it's already there for you because it makes the video a little quicker anyway. So let's just take a look at the student's test and see what they did. And then you can find your mistakes. And I want you to really redo the problems if you missed the problems. Okay. So let's take a look and see at the student's test. Okay. I blurred their name out. Obviously, they got a 60 out of 60. So anyways. All right. So number one, your job on number one was to find X, and you need this angle, right? You're given this angle right here and this side. So you could have gone through and found the other angle right here, but you didn't need to, okay? So this student said, well, I see this. I have, well, the opposite, this is your hypotenuse right here. And most of you did well on this, by the way. So I'll go fast because most of you got this. This is your adjacent side. And so what is, we have an adjacent and an opposite. Adjacent and hypotenuse. Adjacent over hypotenuse is cosine. So the student used cosine. And so the student just said the cosine of 41 degrees equals x over 0.3. And then they multiplied both sides by 0.3. And they got that x equals 0.3 times the cosine of 41 degrees. And they got approximately 0.2 for their answer. Okay? So the next problem, the next problem was number two. And this student used, they didn't even find the other angle. You have 37 degrees here. And what do you have here? You have an opposite for x and an adjacent for 89 degrees. And so what is opposite over adjacent? It is tangent. Remember your SOHCAHTOA rules? So this student said tangent of 37 equals x over 89 because this is your opposite side and this is your adjacent side. Multiplied both sides by 89 to cancel out those 89s. And so now we just have x equals 89 times the tangent of 37, which gave us approximately 67.1. Okay? All right, the next problem here. This student was trying to find x here, and we have this 69 degrees here. So what do we have here? Oh, it looks like we have an opposite and a hypotenuse. So when do we use opposite and hypotenuse? Yeah, we use it with sine. So this student wrote the equation sine of 69 equals 4 over x. Opposite over hypotenuse, right? Then you just multiply both sides by x to get x out of the denominator, and then divide both sides by sine of 69 to get x by itself. And so now we have x equals 4 over the sine of 69 degrees. And when you put that into your calculator, take 4 and divide it by the sine of 69, you get approximately, what was that? Approximately 7.3. Is that right? All right. The next one is you want to find this angle x. Okay, so now we're finding an angle, not a side, but an angle. So now what we want to do is let's see here. We have x, and we have, what do we have here? We have a opposite and we have an adjacent. So now we're going to use tangent. So the tangent of x is equal to the opposite over the adjacent. Remember, that's what tangent is. It's opposite over adjacent. And so now the opposite was 20 and the adjacent was 9.7. But remember, guys, we're trying to find x, not tangent of x. So we have to inverse tangent both sides, and inverse tangent cancels tangent. which just gives you x, and the inverse tangent of this gives you approximately 64.1 degrees, and you're done. All right, so this next one, number 5, here's where most of you made your mistake, okay? And here's the key: angle of depression. Now, what is an angle of depression? If you look up here, an angle of depression is not inside your triangle. It's outside the triangle. So if this person is looking down here at it, this is the angle of depression right here. It's 48 degrees. Now notice your angle of depression is not inside your triangle. So how do you get it inside your triangle is, remember, alternate interior angles gets it inside your triangle, because alternate interior angles with parallel lines, you can move that in there and you can put it right here. So remember, an angle of depression is equal to the angle of elevation. So your angle of depression is always equal to your angle of elevation. So you have to put that you have to rewrite it inside the triangle. So a lot of you made like a right triangle here and did that. No, you want to put that inside your triangle using this, okay? Alternate interior angles. Okay, so once you do that now, you're going to have an opposite and you have an adjacent now, because we moved that inside the triangle, and now we can use tangent. So the tangent of 48 equals 946 over x. Then we'll multiply both sides by x to get x out of the denominator. And so now we have x equals tangent of 48 over 946. We'll divide both sides by the tangent of 48, which cancels out here. So this problem boils down to just saying that x equals 946 divided by the tangent of 48. And you put that in your calculator and you get approximately 851.8. And you're done. Okay, the next problem. Okay, so Austin spots an airplane on the radar that is currently approaching in a straight line and will fly directly overhead. The plane maintains a constant altitude of 5750. Okay, so we know it's always going to be 5750 because the plane's going to stay there. All right. Austin initially measures the angle at 15 degrees at point A. At some time later, he measures it at 33 degrees. So here's the first time he measures it, and here's the second time he measures it, okay? All right, so from point A, so you're basically figuring out, okay, what is this distance from point A to B? All right, so the first thing you need to do is, let's see here, you need to find x and you need to find y, because if you take x plus y, that's going to give you your total distance. Okay, so when you find x is the 15-degree original one, so we're going to use this one right here. So we can say tangent of 15 degrees, because remember, it's opposite over hypotenuse, opposite over adjacent, opposite over adjacent. And so now we have 570, the tangent of 15 equals 570 over x. Multiply both sides by x to get x to cancel out, so these x's will cancel. And now we divide both sides by tangent of 15. And so we now know that tangent, or x, we should say, is equal to 5750 divided by the tangent of 15. And he came up with this number right here, or this person came up with this number right here of 21,459 feet. Now, they repeated the same process with y, except now you're doing a 33-degree angle, a bigger angle, because the reason it's angled because it's angling up more. You're looking more up because the plane is closer to you, so your angle is going to be steeper to look up. And did all the math there. Same process. Tangent of 33 degrees equals equal what 5750 over y. It's right here. And then you multiply both sides by y. So the y's will cancel out on this side. So now you just get y, and then you divide by tangent of 33 from both sides. So y equals 5750 over the tangent of 33. And so when you do that, you get approximately, what do you get? This number right here, 8854.24, that number right there. So now, you remember, you're finding the total distance. So how do you find that total distance? Well, what you have to do is you have to use the original number x. I said add, but we were actually going to subtract here. You're going to find the original number x, which was here, when the first angle, and you subtract off the second angle, and that difference is going to be how far it traveled. And that case is going to be 12,605. So remember, this was your x value. This was your y value you found from your second triangle. You subtract the two, and that will give you your total distance. You don't add them. You subtract. This is your, sorry about that. This is your, let me erase that, total distance right here. Total distance. Okay? All right, so let's move on. All right, the next one. Now, this student chose to use 30, 60, 90 rules. Okay, so let's see here. This, first of all, what did this student do? So they took 360 and divided it by 6 and got 60 degrees. And they divided that by that and got 30 degrees. So this angle right here is a 30-degree angle, and this angle right here is a 60-degree angle. Now, remember that, and then this is a 15 right here. So remember, on a 30, 60, 90 triangle, long leg equals short leg times the square root of 3. So we know that long leg is 15. We don't know what short leg is, but we know we're going to multiply that by the square root of 3. Divide both sides by the square root of 3 to solve for x. And then you rationalize. Right here, he's rationalizing. Okay, and then we get x equals 15 roots of 3 over 3, reduces down to 5 root 3. So this little piece on x right here is 5 square roots of 3. All right. Now, the next thing we need to do is the perimeter of that is, since there's going to be 12, actually, excuse me, there's going to be, this is a hexagon. So this is going to be, there's going to be 12 of these, right? To find the perimeter, you've got to multiply this by 12. And so in this formula, this part right here is the perimeter, right? This part right here is the apothem, A. And this is just part of the formula. So area equals 1/2 apothem times perimeter. Well, the apothem is given to you, so you just multiply it all out, and then just this becomes a calculator problem, and you get about 779.4. And you're done. Okay, so the next one we have is number 8. And this one is a pentagon that is circumscribed into a circle, okay? Or inscribed, a pentagon inscribed in a circle. So what we're going to do now is we're going to, what are we going to do here? We're going to, well, first of all, we need to figure out, when you do the math here, I believe this whole thing here is 72 degrees. And then you divide by 2 and you get 36. So we need to figure out x, okay, and a. In this problem, we need to find x and a. So what if this is a 36-degree angle right here? You say 36 degrees, the cosine, because with a, we're using the adjacent. If we're using this angle here and this a right here, we're going to need the adjacent. So that's cosine, because we have the hypotenuse right here. So adjacent over hypotenuse is cosine. So cosine of 36 degrees equals a over 8. We just simply multiply both sides by 8 right there. These 8s will cancel. And then, so a equals 8 times the cosine of 36. Okay? Now, to find x, we're going to use sine because x, let me erase all this because this is kind of messy. I'll do it in a different color here. So if we're going to find x, we're going to still use the 36-degree angle, but now we're going to do x over 8, which is opposite over hypotenuse, which is the sine. So sine of 36 equals x over 8. Multiply both sides by 8. So x equals this 8 times the sine of 36. So now we're ready to do our math. So remember, we're using the formula 1/2 AP. Area equals 1/2 AP, where A is our apothem and P is our perimeter. So now we just say, okay, so 1/2 A. Well, in this case, A was just our x, and we solved for x, and we figured out that x equals 8 cosines of 36 times P. Well, since this is a pentagon, we have to multiply by 10 because remember, A was, A was 8 cosines of 36, right? So this is actually, this is your A. This is your apothem right here. This is your perimeter right here. So we figured out that x is right here. There's going to be 10 of those sections to get you all the way around the pentagon. So it's going to multiply by 10, and then this was one of those little sections, x. Put it all together, do all the math, all that good stuff, and you get approximately this. Now, you're not done yet because what you have to do is, remember, we're finding the area of the shaded region. So we have to go, remember, and Mr. Roden gave you that formula that's pi r squared, right? And so r is 8, so this is going to be pi times 8 squared, which is 64 pi. That's going to be, this is the area of the circle, the entire circle. So if you take the area of the circle and you subtract the area of the pentagon, then you get the area of the shaded region. So 64 pi minus the area of the pentagon gives you approximately 48.9 when you put it into the calculator. All right, let's keep moving on. Okay, so I gave some buku points on these for law of sines and cosines. So the first thing is you need to name your triangle very carefully. So he named it V. He started VWX. Okay, so little w lies opposite angle W. So if big angle W is here, little w goes right here. See that? So that's really, you got to be really careful. Angle X is 126 degrees. So angle X is 126 degrees right here. And we know that angle V is 51 degrees. So what do we have here? We have angle, side, angle, right? Is that what we're given? Angle, side, angle? Angle, side, angle. So when we have angle, side, angle, we're going to use law of sines. We're going to use law of sines, okay? We're going to use law of sines. Now, to figure out, you can figure out this degree right here because you can just subtract it from 180. That's what he did. And you get 3 degrees right here. Okay? All right. Now, obviously this wouldn't be an equilateral triangle like this, but that's fine. So now we can do law of sines. We could say sine of 3 degrees over 6 equals sine of 50 degrees over V, because what we're trying to find here is we're trying to find V. So we cross multiply down here, and doing the math here. We cross multiply, and you can just see, and if you have questions on the cross multiplication, you get V equals approximately 89.1 centimeters. Okay. All right. The next one is, what do we have here? We have our triangle FGH, and we can see that we know that F is opposite angle F, which is 690. We have angle H, which is opposite of capital H, which is 860. And then we have, what do we have here? We got H is 52. So what do we have now? We have angle, side. Now, angle, side always implies law of sines. Okay? So you just put that stuff into that. We say sine of 52 degrees. So sine of 52 degrees right here over 860 equals, change that color to, equals sine of f degrees over 690. And then you just do the math. And on this one, since we're finding an angle, remember they want us to find an angle, find the measure of angle F, we're going to use inverse sine in our final answer. When you do the math, you need to take the inverse sine. And that's a key thing because you're finding an angle. You have to find your inverse sine after you cross multiply and divide. So remember, I'm not going to do all the cross multiplying and dividing, but you got to cross multiply those and then divide to get your sine of f by itself, because their goal is to get sine of f, and that's worth 5 points if you did that. Now, if you still have questions on this, guys, you can definitely come see me during 7th. So hopefully this video is helpful to you. All right, so the next one is we have LMN. So we have LMN. So LMN. So little l lies opposite of angle L. So there's L. Little m lies opposite of angle M. So there's little m right there. And we know little n lies opposite of big N. So there is little n. And so we don't have any angle information. What we have is we have side, side, side. And side, side, side always implies law of cosines. Law of cosines. So we're going to use the law of cosines on this one. So what do we do here? So we're trying to find, what are we trying to find here, class? We're trying to find the measure of angle M. Okay? So in order to find the measure of angle M, we have to start with side M. So we're going to say side M is equal to side N squared plus side L squared minus 2 times side N times side M. Okay? Or L, sorry. Times the cosine of M. Okay? So you're just doing that math there. And now you got to be really careful with your math. So first of all, you probably want to do your squares. This answer right here comes from these two right here. And then you have to take this number right here, comes from this one right here, right? And then, this whole stuff right here. So comes there, and you still have your cosine of M, and then you want to subtract both sides by, we have to subtract this side from both sides to get rid of that, and then we have to divide both sides to solve for cosine of M. So this whole problem boils down to cosine of inverse of M of negative 113.96 over negative 114.84, and we come up with 7 degrees when we do that. Okay? All right. And the last one is on this section is, well, we know that T is little t, which lies opposite of angle A, is 800. Little t is 900. We know that little u lies opposite of angle U, which is 830. And we know that little v lies opposite of big V, and that is going to be 590. And it's the same thing because we're trying to find angle U. So we're going to start out with little u squared. So remember, guys, this is little u squared equals, well, let's see here. So 590 was little v squared plus little t squared minus 2 times little v little times little t times the cosine of v times the cosine of v. And then you just do all the math, and I'll let you just kind of look at the math here and observe, and you can see it just becomes algebra here. So if you have any questions, you can see what this person did right here. Okay? All right. Now, keep moving on here. Should have more answers here. All right, let me see here. Oh, my resume. Plus 12. Let's see here. More answers here. Looks like we're missing a page here. Sorry about that, guys. I don't know what happened. I got rid of one of the pages I scanned, so I had to rescan it really quick. All right, so 13 or whatever, and what number we're on. This next problem, write a vector using coordinates. So we were originally given a magnitude and a direction, and we need to write it in coordinates. So that means we have to find the x value and the y value. So if we're going to find the x value, that is going to involve cosine, because cosine is the x value because we're talking the adjacent. So if we come over here, cosine of 53 degrees equals x over 13, and we just multiply both sides by 13. So we get x equals the 13 times the cosine of 53, which we get 7.8. So there's where we put 7.8 because this is our x value. Our y value is going to be the sine, because remember, sine is opposite over hypotenuse and y is opposite. So sine of 53 degrees equals y over 13. Multiply both sides by 13, and we get y equals 13 times the sine of 53. And we get y equals approximately 10.4. Awesome. All right, now we're moving on to the next one is, okay, we want to describe the vector below. And what we need is we need the magnitude and the direction. Well, the magnitude is going to be the hypotenuse of the triangle. So it's just c squared equals 12 squared plus 5 squared. Do all the math there, you get 169. Square root both sides, and you get 13. So we know the magnitude of this is 13. The next thing we need to do is we need to figure out the direction. So we're going to do that by finding this angle. So what do we have here? We have opposite and adjacent, so we can use tangent. I guess you could have also used sine or cosine. Now that you know that's 13, you can use any of them. But with that being said, you just take the tangent of theta is equal to the opposite over the adjacent. That's the opposite. This is the adjacent. And then obviously, since you're going for an angle, you're going to have to tangent inverse both sides to cancel out the tangents. So this problem just boils down to taking the tangent inverse of 5 over 12, which gives you approximately 22.6 degrees. So the vector has a magnitude of 13 inches and a direction of 22.6 south of east. Because remember, you're south of east. Okay? All right, the next one, you want to find the resultant. Well, all you have to do on that is you just need to find the sum. So all you do is just add them up. -7 plus 11 and is what is that? That's -7 plus 11 is +4. And then you add 8 and -9. 8 plus -9 is 8 minus 9, which gives you -1. So your resultant is 4, -1. All right, to find the resultant of these two vectors, well, it looks like one of the vectors given is -1, 4, which is this guy right here, this vector right here. And your other vector is -7, 5. That's this vector right here, this green vector right here. And then you just add them together and you get this. And then you're just doing tip to tail. So you just take the resultant is this blue vector right here. And then if you put the this orange vector right here and you just move it up, or this not orange, this purple vector right here, and just move it up here, the green plus the purple will equal the blue. That's the tip to tail method. And then the last one is just basically graphing two vectors and getting a sum of 6, -8. All that I looked for is when you added your two vectors up and you graphed them. So you had to graph your two vectors here, and you graphed them that they would add up. The two vectors that you said on the graph would add up to -6, 8. And so this student chose V 2, 4 and C -8, 4. So 2, 4 is this vector right here, and -8, 4 is this vector right here. And when you add them up, you get this number right here. You get this resultant because 2 plus -8 is -6, and 4 plus 4 is 8. And there were lots of different answers you could have gotten. And we're done. So make your corrections, get them to me as soon as possible, and I'll give you a half point for each one you get correct. All right, see you later. Bye.